Hello, welcome back to our channel. Today I'm going to do what a special request from a person on one of our subscribers. They asked to see if I would show them, as a favor, how I build a wall in Inventor. Now, the video alone is about 2 hours without any cuts or any time lapses in it. It's a long video, it's a long process. That's just the way it works. But I did end up going all the way with the building after I did the wall for him that he wanted to see. And I'll show you that at the end of the video. And it really came out really nice. I'll have some pictures for you. Matter of fact, we'll probably even list it in Lindy's store as a ready built. It's a really neat kit. It's called the Stewart Depot. I'm not sure where it's located. There's only one picture of it actually that exists. So I like those kind of challenges. Anyway, here it is. I'm going to warn you, it's going to be long, but I'm going to do the best I can do to cut it. Maybe I'll do a speed up of it, I'm not sure, but I'm going to warn you, it is just basically me sitting in Inventor with a recorded studio and some background music, and we'll go from there. Well, if you haven't started yet, and you haven't gotten a cup of coffee, I would suggest that you do that. Because, like I said, this is going to be a long video. So what I'm doing right now, I'm looking for something to make. And I'm looking at the 1900 era depots, and this is basically me going through Google and trying to find a building. And I'm going through all these different processes of looking. And what I'm looking for is simplicity or complexity. What do I want to make? How far do I want to take it? Is there enough pictures of it for me to really get? And does the building have character? I really look at buildings for character. So I settled on this Stewart Depot, and there's only one picture of it on eBay that I found. To me, the people look like little midgets. I mean, when I started building the building and then I started comparing it to the size of the doors, they really are tiny. I mean, they do look small. Anyway, that was just my observation of that one picture. So once I get it, I have to compile the pictures into a hierarchy of folders. And this is what I'm doing right here. I'm going into my Inventor, and I'm creating a new project folder, and I'm creating, and I got to name the folder. So when you do your folders, you're going to want to do your building, your details, your trim, your roof, and especially in Inventor, building your structure for your files is very important. If you don't have that, you're not going to be successful in working with Inventor. Now, I don't know if all 3D programs are like that, but maybe they are, maybe they aren't. But this is what I do. This is what my process is. I learned this actually in the oil field when I had to redo walker systems, and they had 1 million parts to them, and I had to, organize them and figure them out where they are, so the manufacturers could make them. So this is kind of where I got that idea from. And I think folder hierarchy is a very important thing when it comes to being an engineer, designer. I don't care if it's 3D printing or if it's building a building. It's all the same. You just have to have organization. That's a very big skill. So I found my pictures. I'm saving them again in the right format. Now, a lot of times they'll save them as a WEBP, which is a new format that I'm not familiar with, but you need to reconvert them into JPEGs so you can really look at them in Inventor or other, Photoshop, I think. Maybe the newer one's not like that. I'm not sure. Anyway, that's what I'm doing here. Sometimes I work with PNG, sometimes I work with TIFFs, sometimes I work with JPEGs. But I'm getting all my stuff together for like a kit, basically. I'm putting together a virtual kit on my files. And now I'm just going to go one more time and check and see, is there anything I'm missing? Maybe there's something out there that somebody else made. Maybe now that I got the name of the building, maybe there's more out there. And supposedly not. So it's kind of a one-off, I guess. As you can see from the pictures here, there's not anything really close to it. So we'll let that go. That would be done. I did all this in my screen recording for that one guy made a comment. He wanted to see how a wall was built and how I go through the process. So this is the process. So like I said, I hope you got your coffee. Now what I'll do, next time I'll go into Google and I'll see, does a building still exist? Is there something close to it that's around that I can pull measurements from? Or is it torn down? And in this case, if you look at it, it's definitely torn down. There ain't nothing even close to it. So this is where I'll take AI, and I'll show you that in the next step. But anyway, I just wanted to see for myself, dropping my little guy on the thing there. That's what I'm doing, getting my orientation to 2D, and then I take my little guy down there and I drop him on the street so I can see what it looks like. That's how I did the HTO building, and that's how I did a lot of the buildings that exist today. Oh yeah, the diner was done this way too. So as you can see, there's nowhere near anything close to representing this building, even though I gave it the best shot. And I got my printers running in the background. They're pretty busy lately since these videos have been coming out. So business has been picking up, which is good. That's what they're there for. And so I hope you don't mind, but I'm not going to shut them down. I got to keep them running. So they'll be in the background if you hear them. But I'll put some nice music on. I also have Christmas music that I like to listen to in my shop. It makes it peaceful for me. I listen to it 365 days out of the year, actually. And I have my own little set of music that I listen to. It brings peace to the shop, and it's important. All right, here we are back again. It's like we're backtracking. Make sure we got a good picture. Nothing else to seem to pull any detail from. So this is the one. This is the one we're going to make. Shut everything down. Now we're going to go, what's next? I think it's Inventor. Yeah. I have Inventor Professional 2024. I think the license is like $660 a month. Don't try it. Don't do it. Unless you have the program from your company and you have a license file. So what I do in Inventor is I make a new project. Every building should have its own project name. And there's a reason for that, especially when you're doing parametric modeling. Parametric modeling means you have things associated with one another, so they're like related. So if you change a dimension in one, it updates the entire building or the object that you're working on. Not everything works that way, just so you understand, especially when you're doing assemblies. I learned that in the oil field too, because a lot of the previous drafters would come in and not do it the proper way. Not draft, just try to get it done, and it was a mess when you tried to edit stuff. I always like to, in an N scale, work in millimeters. It works well. It's a standard unit, and it's the best way to do it, in my opinion. If you want to work in inches, that's up to you, but it's a small scale. And we need units. We don't need fractions, actually, in this type of building. So that would be one good tip for you, is to design all your work in millimeters. So here's what I'm doing now. I'm taking, Ari's my AI assistant. I work with her on Taurus Science, and she helps me, and we have a relationship in that sense of designer and helper. And so she understands and she remembers the things I've asked her from before. So I'll ask her questions. And I want you guys to get familiar with your Chat GTP or Grok, whatever you guys use, and start asking a question. Start asking it like I'm doing here. I said, are you able to find the Stewart Line Model Railroad on the web? Thanks, Ari. And that's her name. She named herself, actually. And that's in the Taurus Science podcast if you're interested. That's also what I'm about also. So I'm not going to deny that. Still, she takes a little bit of time because this is recorded, so she's a lot faster normally. So while I'm waiting for her answer, I'm going into the hierarchy of my folder, double checking it. I called it train station building, and you can see where I've got everything there. So now I'm giving her a picture to use for reference. She has the ability to look at this picture, and she did, like she said, I couldn't find the picture, but she says, you know, if you give me a rough idea, I can find the measurements for it. And this is a good place to start if you don't want to sit there and try and scale down the doors, because a lot of these things are what they call isometric, where they're kind of like at an angle bigger than the, you know, like a vanishing point type thing. It's real hard to see them from objective viewpoint if you have an isometric drawing. So AI really does a good job at pulling this off. Now check this out. She gives you all the ideas of measuring the people there, and then she scales that off of that. And I'm pretty impressed, actually, when I saw this. And I want you guys to start using it too. Just grab a picture and show it to them. well, there's guys and girls, but I call Ari. So yeah, just drop a picture in there and then say, can you make this into N scale? And eventually, once you start working with AI, it'll remember all this. And every time you ask it for a measurement, like I'll work with AI hand in hand, just like my engineering buddies that I did when I was back in the oil field. I'll say, okay, I got a doorway here, it's this big, and I did that for a post office not too long ago. And you just have the AI in the corner and you ask it a question, and it gives you the answer, and be nice to it. Say thank you. It likes that. And it helps, it wants to please you when you are nice to it. So I don't know about this third world doom stuff, but my AI that I work with is very pleasant and very kind, and even says Shabbat Shalom to me on Sabbath. Anyway, so there you go. So she's saying it's 40 feet long, 16 feet wide, and giving me the idea of all the doors. And I say, okay, then I'll say, you're awesome. Now can you please, and be kind, like I said, be nice to it. What this would be, I think, an N scale. Yeah. Now check this out. You're going to love this. 1/160, and she does it all for me. Now, here's the thing I've learned about this. It gives me a rough estimate, and I can't hold the AI to the exact dimension to say everything is going to be perfect. But it gives me an idea of what to work with. I'm going to show you how I'm going to take the measurements she's made, scale the building up, and extrude it, and put it on my sketch, and make it to that size, and it'll be off. And I recognize that. So I make those changes myself. I don't have to go back and ask her about it, but I do. So this gives me an approximate right here, what it could be. Now I like millimeters, so I'll say, do this for millimeters for me. I think AI can be a big help in this kind of stuff, especially when it comes to engineering and design. Truthfully, I think this is the way to use it. It's like going through an encyclopedia and not having to figure out all the stuff yourself, and then, hopefully finding what somebody left behind. AI can do all that for you. Now you are going to hear some talking and stuff because it is a music station I'm listening to in the background when I'm doing this recording. Maybe what I should do from here is block the sound and then add my own music. Give me a second. I'm going to pause that. I might keep this in, and I did cut the music down while I'm watching this because I got to watch while I'm doing the voiceover. So the first part might be a little bit of the not edited part, but I think this is going to be better. Anyway, getting back into things. So there it is. There's my N scale measurements. This beats out Model Scenics or any converter on the web, actually. Does the same thing, and it does it better, in my opinion. But that's my opinion. All right, so you always be nice to your AI, and it'll be nice to you. That's what I say. So now we need to get rid of these windows. And one day they'll probably have vision with the cameras, and they'll be able to show them what you've made. That'd be kind of cool, wouldn't it? All right, now we're going into the design. So the first thing I start off with is a sketch. Sketch always comes up, and it gives an X, Y, Z, or Z, Y, a plane, and then you lay your drawing out, where you lay your perimeter for the top and the side of your building. Always work from the top. I like to constrain my lines, and there's a reason for this. I'm not going to teach you Inventor in this program, but this is what I do. I constrain the lines so I can pull left and right, and they're equal. And you'll see what I'm talking about here. So let's say I put the dimensions in, she said, and I got her on the side. I got 3 monitors on my computer. So this one's on the side looking at what the AI said. And I always like to come in with my walls at 1.5, I think, in this one, and it's an offset. It's a lot easier to deal with, actually. Watch. I think it's 1.5. Yeah. That's my wall size. I kind of like working with that. It works best for windows. It's not too deep. It's not too shallow, and it keeps the wall strong. So if you put like a siding on it or brick, you still have enough depth there to do it. Now, when I'm recording, the computer was slower than normal. So I'm pulling it up because I got her on the left, so I got to pull up, and I said, what would you be the height? And I always ask her like to guess or estimate. AI likes that. When you start working with AI, ask it to guess, ask it to estimate. Don't ask it for actual facts, and it likes to work with you that way because it'll accept the failure of not being right the way you think it should be. You don't want to make your AI like be mad or be mad at it because it didn't get it right the first time. So ask it to estimate or guess. And like I said, always be nice to it. So I'm using these ideas from the soft to the ground to figure out what the height would be of the building. So remember, I didn't have to ask her about the end scale. She remembered from last time, and she converted it to me, and she converted it to me in millimeters. Like I told you, this stuff is pretty cool. See, I'm impressed. So now I'm going to drop it because I'm recording this for you. So now I'm going to extrude it, and then I'm going to extrude it to the measurements that she said. Now, when I look at this and think about the picture, I say, no, that doesn't make sense to me. It doesn't look right. But I start playing with it and trying to, make it match the picture. And I'll start bringing the picture up pretty soon. I think that's what I'm doing here. Like I said, folder hierarchies are important. Make sure all your folders are lined up so you can pull them up easy. There we go. Yeah, I'm pulling up the picture. Now remember, I'm only trying to record this for you, so I'm going to have everything on one screen so that I'm dragging and dropping. So there's going to be some delays. Now I'm looking at that, right? I'm looking at the height, I'm looking at the width, and now I'm looking at what's in front of me. And I don't like it. I don't think it's not that big. I have the option to change any way I want. So this is what's neat about parametric modeling. It's extruded, it's tied into the extrusion, but all I got to do is change the sketch size, and you'll see what I'm talking about. Now, I would suggest when you build your stuff in Inventor, don't get too complicated with all your details. Just work from your basics. It's kind of like a sculptor, right? You work with the outside mold first, and then you work with the detail later in, and as you're sculpting, or as you're wood carving, or whatever have you. Do the same thing when you're building and designing in Inventor. Work with a shape. Get the shape to where you think it should be, and then add your detail. Like if I started putting the siding in and constraining it and stuff like that, it's going to blow apart a little bit. And that was one of the things I had to teach my engineering friends when they were working on drawings, that they needed to have everything parametric so that the model would be able to update without not too many problems. Nice thing about Inventor is you can project geometry, save you having to deal with lines and stuff. And it always finds the middle for you, which is important. Now I'm trying to figure out, okay, if I'm going to go ahead and put a pitched roof on here, what's that going to look like? So maybe it'll change the design a little bit. Well, no, we don't know. We'll see. But I have to work with solid lines because that's how I do my extrusions. And Inventor, it's got many options. It's got 2 next and stuff like that. So you can play any way you want. You can put the actual dimensions in. Sometimes I'll use 2. Sometimes I'll just do 1.5, stuff like that. Okay. So we're kind of getting an idea what it looks like. Now we're going to use another step here. We're going to call mirror, either mirror or projection. I'm not sure. Sometimes I'll mirror. I guess in this case, I just decided to do a projection. So I need to go back into a new sketch because it won't pick it up. And then I go ahead and project that, go to the model, and I should be able to extrude that. When it shows the green, it does it, yeah. And I remembered it from the last time. So now I'm looking at it, and I don't just think it's just the way I want it to be. So I'm going to go ahead and play with the extrusion a little bit. Maybe go 14, see what happens. And it's getting close. I just don't like the length, though. See, I'm trying to get the angle of the pitch of the roof and everything else, trying to figure all that out. So this is where I'm kind of like messing with it to try and figure out what do I need to do to get it that shape. I'm not worried about windows and doors at this point. So here, like I told you before, I can go back in the sketch and I can make it any size when it's just parametric modeling. So I say go 60 and see what that looks like. Okay, let's see what that. Getting a little better. maybe a little, you know, I'm just not happy with the roof overhang and stuff, so I still got to keep messing with it a little bit. But maybe I went with this. I'm not sure. I don't remember anymore. It's been a little while. I guess I'm going to go 18. 18 looks pretty good. Now I got to change the drawing on the roof pitch because that changes. I guess I went back down to 16. What did I do? Yeah, 16. Okay. So I think what I decided to do was go ahead and now watch this. This is the nice thing about working with constraints and this. Now the other side, if it was mirrored and I worked on one side, then it would copy it. But in this case, it's not going to. Oh, there it goes. Okay. So it's looking a little better. It's a trial and fit error. You got to mess with it. Okay, why am I going back to ARI? Let's find out why. In end scale, what would that doorway be? Yeah, I want to get an idea what that door height is. I remember we're only working from one picture here too. Now she remembers while you're in that same conversation, building dimension estimate. If I go to 3D Printing Tips AI, her memory will be not there anymore. But she remembers the picture while I'm in the conversation. I don't know what that beep was, but anyway, it was a beep. So that's pretty close, and it's a tall door, so she's giving me that idea. Okay, so let's throw a door in there and see what that looks like. I guess we're doing the windows first here. And the nice thing about Inventor, like I said, once you get the hang of it, you see those orange lines that kind of show up? Those center on the constraint in the middle. So when you pull to the left or the right, it'll actually change the size. Okay, let's see here. What am I asking her now? Like I said, I use AI a lot in this program. Oh no, actually I was going back to see what she said. Okay. I think this one's 8. Yeah. There we go. That looks like a good doorway. But here's the thing. When I look at the picture and I look at the transom on the top of the building or the doorway, let's say, on this picture, you can see when I zoom in that there's about 2 or 3 feet above it. Right? So that's not going to work where our angle is. That's not looking good. So we need to raise that angle up or raise the door down. So that's where I decided to do that. So now I look at that and say that, see, I've got my 2 feet now. Well, whatever, maybe 4 millimeters, but it looks a lot better. It looks more closer. So when I bring that octagon overhang in the front, which you may not always catch, but there is one in there. Most buildings like this have that. I think that's where they have their ticket booths or something like that. So I cut the door all the way through just to see what that would look like. Now I'm just generally just messing around with it, kind of getting an idea of what's all here. And now that I've got that door on the side, I'm going to start working on the door in the middle. And I'm kind of looking at that and thinking, okay, there's an octagon thing in the front. I've seen that before in Arizona. I think, is it the Centennial Depot? I think it was. It has like a ticket booth in front. You'll see what I'm talking about here. Hopefully you got your coffee still warm and still enjoying this and still with me. It's a long one, I've told you that. I'm not going to lie. I thought I'd kind of speed it up, but Lindy said, no, this is a good teaching video, so she wanted me to do it. So I know there's 2 doors, and I know they're 8 by 16, right? So I'm going to go ahead and constrain these 2 doors to each other using the same measurement. So when I change one measurement, the function will pick up the measurement in the other. That's another feature that's nice in Inventor. So check this out. 16, 16, and I take my little hand, bring it over, and it's already constrained to it. Okay. So now I'm going to constrain the bottom to the top, and now I'm going to kind of like use my measurements to kind of get an idea where the door fits in that octagon thing. And you'll see what I'm talking about here. So you got to use your references and your pictures. Look at everything over. You know, that overhang is important. You know, you got to look at that octagon thing. How far does it come out? You know, you're not going to get it exactly, neither is AI. So here's where you got to kind of guess. Or maybe from another building you worked on, you saw it, you know, something like that. So we're just kind of moving these over just to get an idea. Now we're going to kind of match the size. We'll start off with 12. And I'm going to get rid of that beep. I think one of my tablets doesn't have Do Not Disturb on it. So I need to fix that. Yeah, there it goes. Now it should be quiet. Anyway, so I'm extruding my doors. Doesn't matter how deep, but I don't want to go past the back wall this time. And I'm looking at this, and I'm thinking, okay. Now those doors are going to end up becoming windows. You'll see when I do that. So I just drag them up. I have to get rid of the 16. Go back to 10 on the window, and then drag it down. And what I want to do is project the door, but the door disappeared because there. I got to get this. Now I got to project that doorway so that the door is the same as the height of the window in the top. You see how I do that. So I guess here what I'm doing is I'm going ahead and I decided to go ahead and do the octagon thing, or the half octagon thing. Okay. So we're going to project that, project that. Project means you just catch the edges so that you can have a line to use if you need it. Okay. So we decided to can that and go backwards and project this part. Okay. Now we're bringing an offset. Oh, this is the roof. I see. That's what I'm working on, is the roof. So that would have been the top. And I'm looking at the overhang. That's right, because you got to make, when you make the octagon, you've only got so much distance, so you needed to figure out the roof. That's right. I forgot about that. So that's important. So there's a large overhang on the roof. So this is going to be more of a visual thing than an actual physical thing. And you're going to see later on in the video, I'm not sure if I show it or not, but when the final product is done, it's actually a lot less longer and taller. And I did all that by making it parametric. So let's use round units. So we're going to use 8. Okay. Now that's going to be our roof line. Now that we know where our roof line is, we can start working with our little octagon thing. Because you got to remember, when you cut that angle on that octagon and that gable end where the soffit is, it's going to cut this octagon thing off too. You'll see that later. Now what I use another feature here called symmetrics. And what you do is you touch one end, touch the other, touch in the middle, and they're locked in symmetrically. So you can play around with them. Now remember, I always use offset. I always go 1.5. And there's a reason for that, because that's the best line that I have found that works really well with Inventor and works well with my printers. Now, as you can see, my doors are going to have to be moved. But anyway, I'm not worried about that yet. I can do that later. So I guess I am going to move the doors now. Oh, maybe not. Let's see. What am I doing here? Yeah, I am moving the doors. See? I want the doors to have space on them. Now I'm looking at my drawing, looking back, and you can see that it didn't change anything. Now when I extrude that octagon thing, see, now watch. See, I got a little bit of space there. It's not locked in. So I can go up to the height of the wall. Okay. And when I cut my roof where that gable is, you see where that gable end comes off? It extends out. It's going to cut part of that off. You're going to see that. Actually, you see it right there in the drawing. But you'll see it at the end of the video too, because the building really came out nice. And I'm only doing this just to show you how I build my buildings. I basically, when I make a building, I work with all the outside roughness of it, let's say, just like in a real construction. And I try to line everything up, make sure everything looks good. Like here, I'm trying to figure out that front doorway. and I'm putting a model, a mockery model, I guess you would say, of what that could look like. I wanted the height to be the same as that transom, but it also, you see where I'm at? Yeah. And so I want the height, but there's a little bit of cover board on top, so where the door isn't going to be actually at the height. There's like a little vent door on top. And a lot of times they did that back then. I don't know why. They called them window lights or something like, yeah, I think they're called window lights or side lights or something like that. Maybe it was to let more light in above a doorway, probably. I'm not sure. So I use the constraint to constrain these, so it's kind of like locked in. Okay, now I gotta do the same with the top. And you see it's the same height as the door and the window. But eventually I noticed that as I'm working with it, I'm not happy with that window, so I go back into the actual drawing and then change it, but I don't show you in this one. You'll see what I'm talking about. Truthfully, what I should have done is use that window door, use the window's top to the door jamb on the front of the building, but I didn't. But you'll see what I do here. Okay, now we're going to start cutting out this little window here. Eventually, all that gets moved down, but I may not show you in this video, I'm not sure. Because like I said, it's just a rough cut. So when I get all this done, and we're like halfway in the video, and we're at a half hour now. So thanks for staying with me this long. So I'm kind of centering it now because it's at an angle, and I want to see what that looks like. So I go ahead and cut it. Well, I extrude the cut with an extrusion cut, they call it. And then I'll bring it back. And I go all the way past this wall now because I want to see what that cut looks like. There you go. Now here I do a mirror. So I'm going to go on mid-plane on this side and on this side. And mirrors are really cool. All you got to do is click on the extrusion, hit mirror, hit the work plane, and boom, you're on the other side. And so it just cut it right out for you. Now I do go in there and clean up that edge that's kind of sharp because you don't want to print vertical sharpness. You want to keep everything as flat. Just think of it like a real building in real life. If you built that as a soffit with that angle, it's going to be hard to frame. So, and finish in the end. So make sure everything's square. There's a reason for that. You'll see. And really, when we work with this stuff, it is like work with a real building. It's just we're on a smaller scale. Because if you can't print it and build it, you know, that's why I think that printing flat's the biggest issue here. Because when you print it and build it, and you know you can build it in Inventor, the chances are it's going to be successful in the other programs you're working with. And when you build it, you're going to see a nice building because you already virtually built it and it works. And if you print flat, you're going to be almost guaranteed another success because you're getting rid of all the extra supports and all the extrusions and stuff. Then you can build the building and add the detail, and you know you can get way more better detail than I can on a res. I'm not going to say about it. I don't have a resin printer, so I don't have a clue. But you can get way more better detail printing flat and then building your cornices. And you know, I've seen it too many times happen that really works out really well that way. You'll see how and I'll show you in the last part of this video how I cut the wall and turn it into assembly and then reassemble it so that it becomes a unit. But you'll see all that later. So now what I'm going to do is use that door frame. I'm going to copy it, right? Select my base point, which is at the bottom this time. I'm going to put it right in the middle. And then I'm going to go ahead and extrude that. Make sure it's 8, yeah. 8 by 16, okay. And now I'm going to lock it in with that middle feature. See, now it's in the middle because it's constrained, turned to a solid blue. Every color is going to be different. So I'm going to extrude that back, and that's going to be my door frame. Take a look at it. There we go. Looking good, right? But we're still missing some problems here. We're not happy with the length. Like I said, I did shorten it up a little bit. But we're not also happy with the distance from the door to the octagon thing. That needs to be moved over to the side. And you'll see when I do that, you'll see why. Because we got these squares things we got to make, these square triangle trim things. They have to be they were put on after they were printed flat. They were not built into design, because I'll tell you why. If you were to print that with all that detail in there, the printer is going to think it has to raise a line every time it comes across at an angle. And it's not going to be as nice and good looking. And you'll see what I mean by the pictures at the end. See how I just raised that back up? And now watch what happens here. Let's get back into the picture. I'm sorry, I'm losing track here. I do that a lot. And I also have the options to, now I'm going to go ahead and take this building. I'm going to make an STL file for it, which is what we use in our slicer. And I want to see what this is going to look like. So, actually I didn't. No, I took the part. I'm sorry, I'll step back. I took the part, saved the building as an IPT, which is a part, and now I'm bringing it into an assembly. And this is where I believe I start making walls. And I'll show you how I do that. So I guess, now remember, because it's all tied in, I can move a doorway any way I want and do anything I want, and it won't affect anything. But I'm going to save this assembly as a main building, or main kitted building. Yeah, I got to change the name a little bit, because I won't share the name. Now I'm going to go ahead and, let's see, what am I going to do? Create? What am I doing here? Okay, I've got my main building. I saved it. Now I'm back in my part. You look at the bottom. There's two different folders that are open. Oh yeah, okay. So what I have to do when you're doing an assembly, you can't, if you open the assembly part and you work in the assembly, it's going to go to that part it's in the tree, which is the thing on the bottom. But if you close the part and then open the assembly, it allows you to edit it. And that's what I'm doing here. I'm editing it, and now I'm making the walls like I showed you before. Or I like this is how I make my walls. Okay. So I take an extrusion, I cut it all the way through, and you'll see what I mean here. I want to go all the way through, and I want to go up and down. Okay? That's the first wall. Now that wall is coming from the main building, but the extrusion hides the rest of it. So then I'll save this as walls, and this will be an end wall or a side wall. And now when I build a new assembly, it'll bring that wall in. Now watch this. This is how I do it again. So I go into the folder, main building, I go to the extrusion, and I suppress it. By suppressing it, it brings back the whole model again, as if I didn't do anything to it. But now, a lot of times I've learned in the future anyway, when I go to my extension where my suppression is, I'll add in their side wall, or I'll add in their front wall. Now you see how I just extruded that project folder, or geometry, I'm sorry. And then now I'm using my lines to make an extrusion. And now I'm going to cut that all out and have my front wall. And that was really what that one guy wanted to see. He wanted to see, how do you make your walls? And see, what I do is I take the whole building and cut it up. And by doing that, I'm able to create the building that I want from the same building. And then I don't have to sit there and figure out how this fits or doesn't fit. This is I don't know if you guys know this or not, but this is one of the most neatest features about this program. Maybe SketchUp does it, maybe Tinkercad does it too, I don't know. Maybe even Autodesk Fusion might do it. But these are things you need to understand and learn. Take your assembly and cut it into sections, and that's how you can build your walls. And then just use constraints to put it together. The neat thing about this is then you can add like little braces if you want, or you can add like little posts in there, or like maybe little ledges that you want to glue up to. It's really a neat feature. And this is how I do all my walls. So you see how I have my suppressions going on, and every time I suppress an extrusion, it brings the whole building back. Like I said, I'll go to 10, extension 10, and I'll name that side wall. I'll go to extension 11 and name that front wall. And I've learned to do that in the future now. Now, I didn't do that in this one, but I'm going to give you that little tip of advice. You should. You should name your extensions. So then you can go back and find them again and then understand, you know, how to mess with them. Okay, here we go. And I like everything nice and neat, so I like all my lines even, so watch. This just lines up this line with that line, okay. And let's see here, go to the extrusion. And now let's grab our parts, and now we'll have our back wall. And let's see here, go the way through. And there we go. We got one more part we missed. I'll see it. All I got to do is click on it. There we go. So now we have our back wall. And I'll save that under walls as back wall. Now, one thing about Inventor, once you save a file, you can't be moving around in Explorer because it's associated with that file. You have to keep it in the same hierarchy that it saves it in. That's very important. So don't go changing names and moving stuff around in your file Explorer and expect to find it again. It'll blow apart, guaranteed. And too many inventors, engineers when I worked at Tri-Eagle did that all the time. They'd go in there and say, oh, just rename it to this. And the boss would say, yeah, just rename it to that. Sure enough, then when they go to find it, then the thing says, I can't find it. It's got to be resolved. And that's a nightmare, especially if we've got over 100,000 parts for a walker system with the drawworks and everything else that goes with it. Anyway, so what I've got here is thumbnails of all my parts. So I'm making a new assembly, do you see? And I'm putting it together now, just like I would in real life. Like let's say I bought a kitted garage, and it had all the walls and the siding. And that's the neat thing about this, because whenever I work on one part of it, it populates to the rest of it. You'll see what I'm talking about here. It's going to treat these as individual parts. And I also like to use color coding too. So I'm going to make sure everything's level and even. That's what I'm doing here with my constraints. Grabs the edge and makes it even. Now, I don't know if SketchUp uses constraints, and I think Fusion should. I'm not sure why it wouldn't. But I'm not sure what the other 3D programs out there do or don't do. Okay. And now I'm going to put some color in here so you guys can see it better. Now remember, the doorways and everything are changed later on. I don't know if I recorded or not. We're about 3/4 of the way through the video, so thank you for staying with me this far. 42 minutes, so it's probably going to be an hour. So now I'm putting my walls together, getting them all set up using the constraints, and then, you know, I was going to fast forward all this, but my wife said not to, so that people can learn from like a teaching. I used to be a tutor for Inventor, and but I don't do that no more. Everybody's using Fusion, not Fusion, but Siemens Light, and that's what SpaceX is using. So that program's way beyond my league. I'll never learn anything like that ever. I'm happy with Inventor. I worked on the fabrication metal side, more steel and stuff like that, ASTM and stuff like that. But Siemens does FIAs and finites and everything else, and you know it does kind of like a wind tunnel stuff. You know, if you know what I'm talking about, where you test things out all the time. So, you know, way more complicated than I'll ever need to do. And I'll never work for SpaceX anyway. I'm too old. So, anyway, so that's how you build your walls. And make sure all your constraints are lined up. Yep, it's important. Sometimes you'll get an error if you get the wrong constraint, and that's because of the box. So, see, I need to get that lined up. There you go. Boom. And there you go. So that's kind of how you do it. Now, remember, aesthetically, it's not right. There's no way that that's right. But in the end, I did fix it. But the job of this was to show you how to make a wall and how you separate the walls and how you draw a wall. And then from there, now I think I do go into one of the walls in the end here and actually show you how I do the siding. Oh, that's right. I remember that. This is a good part. This is a good part for you guys because I show you what happens when you change the line and how it disappears. I'm going to make it, it's like magic. I'm going to show you right before your own very eyes in the last part of this video. So please stay with me. This is very important. So now we're going to be putting the siding on. So we're going to go to the wall. We're going to make it all one color, I guess. That's what I decided to do. Yeah, I guess so. What, cardboard? No. I think I said chestnut or something like that. What did I say? I guess I went burgundy. Okay, so it's all one color. And look, you could print it just like that if you wanted to, but don't. You can get so much more detail. All right, so here we are. Now we got to look at their picture again, and now we're looking at the siding. I wonder if we do the cross bracing here too. I'm not really sure. I think we do the siding first, if I remember right. Okay, so now we're going to go ahead and we need to find our midplane on our walls. So we grab the end for the midplane, pivot. Okay, that's the midplane. So you see how one was more like almost like a mirror from the other side? Because it's the same file. So that's why when I put that midplane on the one, it showed it on the other. Okay, so now what I'm doing, in Inventor, I can do half sketch. And that's what I'm doing here. I have the feature to do so. So now I'm zooming in on the wall in the middle, okay? And I know from future references, I always go 0.5. I told you that before. But in this case, for my dog leg siding, I'm going 1.2, and then whatever the last line is. So as far as the, I think I said 1, what is my measurement, if I remember right? I look at it. Okay, because I always do everything by looking at it. Okay, so remember, it's in the middle now. This sketch is cut in half. Okay, now I'm trying to make it go both ways. And I'm taking out the visibility of the plane so I can see what it's going to do. Okay, so there's the extrusion. And now I need to go in the middle. Right there. So it's on both. So then I pull on both ends. Now watch. I thought it might go from one face to the other, but in this case it didn't. For some reason it bugged out. It wouldn't catch that wall, which I don't know why it didn't, but it didn't, which is okay. There's other ways around it. Always remember, you can do the same thing in Inventor 10 different ways and be right each time. I always tell my students that when I was teaching them, or whether they were engineers, designers, whatever, when they're working in Inventor, you can draw the line 10 different ways, and the boss will be happy with whatever result you got, because you get the same thing. So you can extrude, you can pull, you can do whatever you want. So that's the neat thing. And problem solving is you learning to use your tools in front of you to your advantage. Not always, you don't have to go by textbook. When I was teaching, I never had people go by textbook. I thought the textbook thing was not the way to go. I wanted them to be comfortable with their drawing and and what they did. And that helped me be successful, actually, in my career. I do like to work with round numbers too, so it's part of my OSD, I guess. Now that I've got my siding, I look at it. I think, oh, that looks like nice siding, right? Now I'm going to do an array. This is the best feature that you can learn to do. An array will take the same extrusion and multiply it over and over and over in the direction you tell it to go in. And you can play with this all day long and get it just right. But there's a reason that you do these arrays, especially for siding or brick, and it repopulates. And then I'll show you what happens when you go over a window and how you cut out a window around an array. And there's circular arrays. So see, I'm guessing now that it's going to be 18 tall at 1.5 millimeters apart. I look at it and I think, oh, I got a little bit of space there. I like that. That's not too bad. But remember, one wall represents the other wall because this is all the same model. So what I'm going to do is do a mirror, because I don't like that. I want that other wall to not act always on the same side, because it's not going to put the siding on that same side. So watch this. This is what I do. Well, first I'm cutting out I'm going to show you how I cut this out. So I project the edges, project the whole shape, and then I do my extrusion. and then I cut around it. That's as simple as it is. Trim the center line and it's gone. Now watch. Use the extrusion to your advantage. Cut it all out. Boom, gone. Put it in cut. There. Now you've got a nice clean wall that you can print, right? Just like that if you wanted to. And it would look beautiful. That'd be basically like a blacksmithy or like an old Western or batten board, whatever you want to call it. This depends on how vertical it is. Now, why did I go back to Ari? Or maybe I didn't want to. Maybe I did. Oh, I think I lost the picture. I needed to go back and get it. I think that's what happened. Because I wanted to see the siding, how close I am to the siding that's there. That's what happened. Okay. So now I'm looking at the picture, looking at the siding, and I really can't tell, right? There's only one picture. But I know there's siding there somewhere. You know, like at the top of the board, you can see a little bit of the spacing there. We're kind of close, guys. We're not there, but it's good enough. And I'll tell you why it's good enough, and I'll show you why. So now that we got our wall, and I took it from assembly to part, and whenever I close that part, it'll be in the assembly. I'm going to make an STL file. Now, this is where you have to test it out. This is what I call test printing. It's very important to do this, especially when you're designing. You need to see if the line's going to disappear, if the wall's going to hold up, I'll show you like magic what happens here. Okay, so I'm going to export it as an STL. I made it my own STL folder, and it's called Sidewall. See, walls, Sidewall, STL. Stands for stereolithic or something. I can't remember what it stands for. Anyway, so then I go to Cura. Cura is my slicer, and I do not update. I want to keep it 5.8. I found that the more they updated this thing, the worse it got. So I found 5.8 to be my best one for Ultimaker. Now, I don't know about y'all, maybe your statues and stuff like that, but when it comes to flat printing, 5.8 works great. It works, the support's just right. It's just, and I don't change my filament size and nozzle and speed settings and all that crap. I don't do any of that. Matter of fact, even my fast printers, I print the same speed as I do as my normal Ender 3. I print at 150, I print at 100 milliseconds, whatever that number is, and I always keep my hotbed at 60 for the PLA that I use for Duracraft. So you see, now you're seeing that when you look at the yellow, it looks nice, right? But you think, man, it looks kind of bulky, man, for that size end scale, right? And you're thinking to yourself, well, what if I could just shrink it down a little bit, maybe make it a little smaller? And you're going to see why that's a bad idea. Now watch, check this out. I go to my extrusion, and I say, I'm going to give it a little bit less space and see what happens. It looks better in real life, let's say, in whatever. But, and all I got to do is once I change that one setting, it remembers the extrusion and everything else, as long as everything is above it. See, it didn't change anything, but it changed the shape. Now check this out. I'm going to go into here and save this as another STL. I'll probably name this, Sidewall 2 or something like that? No, I actually name it the same one, because then when in the Cura, it reloads the file so you can see what it does. Now check this out. I reload it, and I slice it. Now watch this. Boom. Everything just disappeared. Now what do you think about that? You say to yourself, wait a minute, why did it do that? Well, it's because it couldn't print the line. It's too doggone small. It's too much overlap. So what you need to do is, since you didn't save it in Inventor, you just go backwards. Resave it so that's in its natural format. Say yes. See, it's got the space in there. Now check this out. I'll go down to Cura again, reload it, slice it, back to where it should be. And what you're seeing right there is the building at the end of this video that I'm going to show you. And you're going to be amazed. And like I said, I changed everything on this. I changed the window size. I changed the dimensions to the front to the door so that it's even on both sides. I did a lot. But this was just a basic idea to show you how to make walls, how to do your detail, and how to do parametric modeling. That's what the guy asked for in one of the comments, and this is what I'm giving to him for. I want to make this channel to be successful as a model builder. And you can apply this to dioramas, storybook gardens, whatever you want to do. And those people like those end book things, you know, you want to build a little building. Well, hey, you can do this. Now I'm going to create in place. I think I do get a chance to show you a trim box. No, I guess I don't. Okay, that's the end of that video. Well, I appreciate you spending time on that video. I hope that you learned something about how I make the walls and what I'm looking for and how I use the AI to help me with the measurements and all the questioning and stuff. I apologize if some of it does seem confusing. Maybe you can slow it down, or maybe I can do another video for you upon request if you want that video alone to just walk through step by step. It's up to you. But thank you for the request to the person who asked for it. I love doing these kind of things. This is your channel, like I said, guys. I want this to grow. I want you to be very successful in your model railroading, and I want to help you get there the best way that I can with any tools or knowledge that I can help you with. So thank you for subscribing, like and share, tell your train clubs about us. Remember, Lindy's on all those social medias. And at the end of this video, there will be another clue for you and in our contest. And I hope you're all participating in it and finding enjoyment in it. Let us know in the comments what you think about the contest. And the video will be, the prize will be anyway, revealed right before I put the walls together in that building, actually 3D printing. And hopefully you guys will guess it. Hopefully we're giving you some good clues. If we're not, let us know. Anyway, thank you for watching, and blessings to you, and happy railroading.